Welcome to another explainer. Today, we're diving into literally and figuratively one of the most mind-bending scientific mysteries ever uncovered. We're going to look at a period in time when an entire sea, the Mediterranean Sea, just simply vanished. I know, it sounds like straight-up science fiction, but it's an absolute, undeniable geological fact. Let's get right into it.
So, I want you to picture looking at a map of Europe and North Africa. But instead of the sparkling blue waters of the Mediterranean, you see a vast, scorching desert depression, a valley plunging miles below global sea level. What if the Mediterranean Sea entirely disappeared? It's a wildly provocative question, right? But it's exactly the impossible scenario that a team of brilliant scientists found themselves staring down, utterly baffled by the evidence right in front of them. And the craziest part? That evidence wasn't found walking around on land. It was discovered 3,000 meters. That's nearly 2 miles straight down beneath the ocean waves. At the staggering depth, where there honestly should only be soft, dark marine mud, scientists stumbled onto the very first clues of a geological catastrophe, so massive it kind of defies human comprehension.
Part 1. The Mediterranean's Hidden Salt.
Okay, to figure out how we actually discovered this, we have to travel back to 1970. The deep-sea drilling ship, the Glomar Challenger, was out exploring the depths of the Mediterranean. Now, acoustic mapping had already shown this strange, highly reflective layer buried deep beneath the seafloor, which they dubbed Reflector M. But when the drill bit actually reached that depth, it didn't just slide through soft, deep-sea mud like it was supposed to. It hit a solid, impenetrable wall. The drill bit just suddenly plugged up, the drill collars experienced this crazy erratic torque. They had hit something incredibly hard, right where an ocean basin is absolutely supposed to be soft. Let's dive into this bizarre evidence for a second. When the crew hauled the drill collars back up onto the deck and dumped the barrels out, they expected deep-sea mud. But, well, actually no, they didn't find mud at all. Instead, they pulled up this completely chaotic and totally out-of-place mixture. We're talking rounded volcanic basalt, shell fragments from dwarfed mollusks that normally only live in super shallow, brackish water, ordinary river sand and pebbles, and maybe weirdest of all, these glittering crystals of selenite gypsum. That's a mineral that forms from highly concentrated evaporating saltwater. Literally none of this belonged in the deep ocean abyss.
Part 2. Impossible Deep-Sea Clues.
We're basically going to treat the ocean floor like a crime scene right now, because we've got totally contradictory evidence that shouldn't exist together, and we need to figure out how it got there. Just look at the sheer contrast on this slide between what marine geologists expected to find and the harsh reality of what was actually down there. On one side, you expect a dark abyss teeming with specialized deep-sea marine life and soft mud slowly piling up over millions of years. But the Mediterranean reality? No way. They were pulling up rusty red desert soils, fossils of coastal algae, and massive, solid layers of salt that could only form if a giant body of water had completely evaporated away. Looking a little closer at our crime scene evidence, they found a coarse sample of salt-cemented sandstone with a 3.5-centimeter deep shrinkage crock. It looked exactly like the dried mud puddles you see on a blazing hot summer day. They also found these chicken wire salt nodules. And this is crucial, because this specific texture only forms today in the blistering hot, shallow desert flats of the Persian Gulf, directly out under the desert sun. And finally, they found microscopic algae that usually only grow in extremely shallow, sunlit water.
Which leads us to this massive contradiction. Think about it. How do algae, which absolutely requires sunlight to photosynthesize and survive, how do they end up buried under thousands of meters of pitch-black, deep ocean water? Algae like this have to grow on a sunlit bottom, or at least attached to floating plants. It just didn't make any sense, unless, at one point, the sunlight was able to reach the very bottom of the seafloor.
Part 3, the desiccation hypothesis. At this point, the pieces of the puzzle were finally starting to align, and they led scientists to propose one of the boldest theories in modern geology. They realized they were looking at the remnants of what Italian geologist Raimondo Celli famously coined the Messinian Salinity Crisis. And listen, this wasn't just some shallow coastal pool drying up in the sun. This was a dramatic environmental catastrophe during the late Miocene epoch, where the entire Mediterranean Sea, a basin miles deep, evaporated to near dryness. It left behind these massive, kilometers-thick layers of salt, basically transforming the sea into a network of hypersaline, deadly lakes and vast desert plains. And you know, the chemistry just doesn't lie. When scientists tested the core samples, the chemical isotopes painted a perfect picture of a dying sea. Bromine showed rapid, high variation concentrations, which only happens in very shallow, rapidly evaporating pools of brine, definitely not deep oceans. Strontium isotope 87 was massively depleted, proving the water down there was mostly runoff from continental rivers, completely cut off from the global ocean. And oxygen isotope 18 values, they were so exceptionally high that they proved greater than 90% of the original Mediterranean seawater had physically evaporated up into the atmosphere.
Part 4. Sunken Grand Canyons. So, as if the microscopic evidence wasn't enough, we then found the massive physical proof. Commercial drilling and seismic mapping revealed fossilized rivers completely buried deep under the modern seafloor. The ancient Nile River, the Nile, had actually notched a canyon over 100 meters deep straight into solid granite. The Rhone River in France had incredibly deep valley incisions. The Sahabi Channel over in Libya was found buried 400 meters deep. And off the coast of Spain, the Ebro margin showed deeply scarred branching river networks that looked exactly like the Badlands. These are literally sunken Grand Canyons. When the sea evaporated, these rivers suddenly found themselves plunging off continental cliffs into an empty basin, violently carving out massive canyons as the water plummeted downward. To create these massive, deeply entrenched river valleys, scientists calculated that the sea level had to drop by at least 1,500 meters, and in some places, much more than that. That sheer vertical drop created a totally new base level for every single river feeding into the basin, basically turning peaceful waterways into raging, canyon-carving torrents. So the crucial takeaway here is captured perfectly by this quote from researchers who are exploring the Nile Delta. They said this event triggered, quote, a great lowering of sea level that would have adjusted the fluvial processes to a new base level, deeply entrenching the old channels and alluvial plains. Guys, we are talking about absolute, unparalleled geological chaos spanning across Europe, Africa, and the Middle East.
Part 5. Solving the Messinian Crisis. All right, so we know it evaporated. We know it created massive desert canyons. But exactly when did this happen and how on earth did it finally end? By using some incredible astronomical calibration, basically aligning the rock layers with the Earth's orbital cycles, scientists mapped an incredibly narrow, sudden timeline for this catastrophe. At 5.96 million years ago, the connection to the Atlantic Ocean choked off, and those massive salt giants began to deposit. By 5.60 million years ago, we hit extreme evaporative drawdown. The sea virtually vanished, exposing the floor to the sun. But then right at 5.33 million years ago, the fossil record suddenly shifts. Deep-sea marine life just instantly returns.
And this builds to just a spectacular grand finale. At 5.33 million years ago, we hit the Pliocene Transgression. A geological barrier at the Strait of Gibraltar finally gave way. The Atlantic Ocean breached the dam and just poured right in. It was a near instantaneous flood of apocalyptic proportions that brought deep water marine species surging right back into the basin, instantly burying our sun-baked desert clues under a layer of marine mud forever. The Mediterranean Sea was reborn in a geological blink of an eye.
It's an unbelievable testament to the immense, hidden tectonic forces that are constantly reshaping our planet, which leaves us with a totally fascinating and honestly slightly terrifying question to end on. The tectonic plates that closed the Mediterranean off 6 million years ago, yeah, they are still moving today. So if the Strait of Gibraltar closed again right now, cutting off the Atlantic, just how long would it take for the Mediterranean Sea to vanish once more? Something to think about. Thanks for joining me on this explainer, and I'll see you next time.